So I want to just take us back to the amazing restaurant that we went to, where there was just 2 of our buddies, there was 6, and there was 18, and so on, and the number of people attending this awesome restaurant was growing in a geometric pattern, where the number of people attending the restaurant was multiplying by 3 each time, and we called that our common ratio, which from then we established how to find the nth term of a geometric sequence if we knew what the common ratio was and we knew what the first term was. The focus of this lesson is I want us to focus on the sum of a geometric sequence. So in order to do this, I'm going to stick with this same incredible restaurant. So just take yourself back there, except this time we are putting ourselves in the shoes of the chef. Just so we can do that, let's say this chef's name is Chad. And now Chad, on the first night of business, he made a total of 2 meals for just you and your buddy. And then on the next night, he made 6 meals, bringing his total meals made up to 8. Okay, summing the number of meals that Chad prepared. After the third night, he would have prepared 26 meals, and we go so on. And so I might pose the question, well, how many meals did Chad make after 6 nights of work? And so you go, okay, you can solve that. This is all you need to do, really. You go, well, it's going to be the first term and the second term. We're just going to add up the first 6 nights, right? Which if we had our calculator and enough time, okay, we could definitely do that, because it would be a little something like this. Which is nice enough if you only have to do that for 6 terms, but what if I wanted to know how many meals has this chef made by 14 days? Well, we could go ahead and find out the first 14 terms and then sum them, but that would be rather time consuming, and surely there's a more efficient way that we could go around this, and there is. So imagine if we were just trying to find the sum up to n terms, okay, because if we know n terms, we can just put n to be any number. And so we know that's just going to be the first term plus the second term plus the third term plus so on, all the way up to the nth term. Okay, we know that the first term is just t of 1, but the second term, we know what that is. Right here. It's t of 1 times by r. Third term would be t of 1 times by r squared plus dot 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 dot, all the way up to the t of nth term, which is t of 1 times by r to the n minus 1. Okay, how we would go about solving this, if we just multiplied this expression here, I'm going to call this expression number 1. What if we just multiplied expression number 1 by r? So it looked a little something like this. So we can see here, I'm underlining this in blue to highlight it, that all of these terms in the brackets are separated by a plus sign. That means that we can apply the distributive law here to expand out these terms. Okay, that would be it simplified out if we extended those brackets, and that I'm going to call that expression number 2. If we did expression 2 and subtracted expression 1 from it, so it looked like this. As we do this, this actually eliminates off quite well, and you have to spot what's happening here. Again, remember these expressions are being separated by a plus sign. So when you're doing the subtraction, the expressions as they're separated by a plus sign can be kind of treated as their own entity when you're doing the subtraction. And so you've got this t of 1 times by r, it's on the top, we're subtracting it away from the bottom. Same as this, t of 1 times by r squared, we can take that away because it's on top and bottom. And this pattern continues throughout the dot 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 all the way up to the r to the n minus 1 term, leaving us with just 2 terms that pop on out. So we get r, s, n, subtract the sum of n terms is equal to t of 1 times by r to the power of n, subtract t of 1. What we can actually do is we can factor out the sum of n terms from both of these expressions, with r minus 1 being left over. And again, we can factor out t of 1 on both of these expressions with r of n minus 1 out here. And we can just divide by r minus 1 and we get our equation. Okay, which is quite nice. Now, just to reinforce this, you are not going to be asked to regurgitate this style of proof on an exam. It's just to show you that when we do use this formula, it's not made up. Okay, so we're not just plucking it out of nowhere. Somebody went to the detailed effort to discover it and have a nice formula, and so here it is. Well, then if we reconsider this problem here, all right, we'll just double check that it actually works. We'll do it in a green. The sum of 6 terms would be, well, t of 1 is 2, outside of r, which is 3, to the 6 minus 1 over 3 minus 1. Okay, that's just plugging in. I'm going to rewrite it up here. Okay, plugging in all your terms here, we can simplify this down. 3 to the power of 6, plug that in your calculator, you get 729, subtract 1 over 2, things cancel out nicely. We do in fact get 728. So this formula, it works. What's business like for Chad after 14 days? Okay, so we don't have to list out every term, we can just plug it on in. Alright, we've got all that information, we put it in on a calculator, and we would get. And so we see here, after 2 weeks, Chad would have made 4,782,968 meals. And so you might ask Chad, hey mate, how's business going? And he'd tell you, not bad. Okay, just as a little note here, as an exercise, we've got these two expressions, 1 and 2, and we did expression 2 minus expression 1. If you did expression 1, subtract expression 2, you would actually get the sum, okay, being equal to this. They both work. You can try them out. They're both the sum of n terms of a geometric sequence. So let's have a look at an explicit, concrete example of what a question may look like. Find the sum of the first 8 terms. So I know n is equal to 8 of a geometric sequence where t of 1 is equal to 4 and r is equal to negative 3. And so what is useful for me straight away is to recall the sum of, okay, from here I know I'm just summing 8 terms. Okay, and so you just crunch some of this into your calculator and you get an answer. Okay, second example, a geometric sequence has a common ratio of 2, so that means r is equal to 2. If the sum of first 5 terms, s of 5 is equal to 100, determine the first term, t of 1. Now, explicitly pointing out, in this case, n is equal to 5. That's super important, because when I plug in my formula, okay, when I plug it in, I need to know that the r, so 2 to the power of 5, because n is 5. We can simplify this out. Okay, that would just be 32 minus 1 is 31 over 1. Okay, so 100 is equal to t of 1 times by 31. So t of 1 is equal to 100 divided by 31.